welcome to another episode of Decentral Lounge, brought to you by GlobalStake, your institutional, truly decentralized bare metal staking service provider. Today, we are excited to have a wonderful guest on the show, Anurag Arjun, who is the co-founder of Polygon and now founder of Avail. Anurag's journey started co-founding Polygon Technology to creating Avail reflects his deep engagement with the blockchain ecosystem. With a rich experience of decentralized systems, zero-knowledge validity proofs, and blockchain technologies, Anurag has a unique perspective on the intersection of fintech, distributed systems, and cryptography. His leadership at Avail is focused on optimizing data availability in blockchain, making it an essential aspect in the evolving digital landscape. Join us as we dive into Anurag's fascinating journey and his insights into the future of blockchain technology. Excited to have you on today. Welcome to the show, Arjun. Anurag. And so go ahead, why don't you just start off with telling us a little bit about how your journey started? How did you get involved in the blockchain world and take us to today?
Yep. Yeah, first of all, thanks, Ryan and Jordan. Great to be on this show. So to start off with, maybe let's me take a step back, just talk a little bit about how I entered crypto in general. Prior to crypto, I joined crypto in 2017 when I founded Polygon, along with JD and Sandeep, for example. But before that, I spent probably about 11 years in fintech and regulatory technology. I've always been interested in understanding how we can better financial technology, especially around rails, payment rails, for example, but also about how data, real world data, can be integrated into rails. So predominantly like programmable money and stuff like that, right? But yeah, I mean, in 2017 is when I kind of entered crypto. That is when we started Polygon. It was known as Matic network back in the day. And we kind of entered the space by implementing a Plasma solution. So Plasma was the previous predecessor of rollups that we see today. So we started building out Plasma first. Eventually, that plan didn't work out, and so we actually ended up implementing Polygon POS. So I spent a fair bit of the last 6-7 years building a lot of the Polygon stack, including the POS chain, the Plasma chain, the bridging infra, for example. Also, crafted a lot of the ZK strategy, acquired teams like Hermes, Zero, Maiden at Polygon, for example. And also actually started building Avail within Polygon in late 2020. This was after we had shipped Polygon POS. So some part of the motivation of starting Avail was that in general, in 2020, rollups were beginning to pop up, and Ethereum had just kind of launched or released their rollup centric roadmap. So they were making a major pivot towards rollups. And so at that point in time, it became very clear that rollups would be very important to blockchain scaling. And so then that's when we decided that we will kind of build infra related to rollups. So on the execution side at Polygon, we pivoted to ZK rollups, and on the infrastructure that surrounds these rollups, right? And we can get into why things like data availability are important, for example, why rollup interoperability is important, and so on. But Avail, if you kind of think of it, is like if rollups are the future of where the blockchain space is going, then you need infra for scaling rollups and also making these rollups interoperable. So that's the infra that Avail really provides. So that's like a brief summary of where we began, and what is Avail.
No, that's a great overview. And one of the things I knew that you had started working on Avail in 2020 before it became spun off to its own thing. And why don't we talk a little bit more about Avail specifically? Because I think a lot of times people only just hear data availability. In fact, you're probably our first guest really from the whole modular movement that we're seeing for season 2. So Can you explain a little bit more for the average person, or maybe institutional investors, like what data availability really is and how this is really just the first base layer to what Avail is building?
Yeah, absolutely. So perhaps a good way to explain this is to first see what rollups really are, right? Like, so rollups are actually really these pieces of computation, verifiable computation that you can do off chain, right? Like, I mean, off the main base layer, right? Like, so essentially, like, before rollups were invented, right, like, you had to put like a computation of any program or anything that you want to run on a blockchain or a verifiable compute. uh, uh, Blockchains basically solve the problem of verifiable compute, right? Like, I mean, in the sense that you don't have to have a trusted party doing the compute, right? Like, so in the initial way of doing this was having a big network of validators, for example, and essentially people are incentivized to run uh, multiple nodes, and so you have one program running um, on each of these nodes. So each of these nodes have to re-execute and then come to some sort of consensus. So that's the initial approach of building any sort of blockchain, right? Like, so if you see Bitcoin or Ethereum or any other blockchain that began, so you have like n number of nodes. That n can be in hundreds of thousands. It could be 100. It could be 1,000, for example. But essentially, you kind of send a transaction. There is some program that is executed. It is re-executed by all the nodes in the network, and then basically there is some sort of consensus, right? Different networks have different sorts, so we don't get into that. But essentially, the problem is that you need to have all the nodes in the network re-execute these transactions, and so essentially you need the same computation has to be rerun every time, right? Like, so by all these nodes. So that is how the first generation of blockchains was. Now rollups are a very strictly a very big improvement, in the sense that you kind of try to get away from re-executing these transactions, right? Like, so you might have heard of things like optimistic rollups or zk rollups, for example, right? Like, so all of these are iterations on the model that you don't have to like this computation doesn't have to be re-executed by all the nodes in the network, right? Like, so for example, in a zk rollup or a validity proof rollup, right, like, you have this magic technology called zero knowledge proof technology or validity proof technology, where there is mathematical this is something called a prover that provides a mathematical guarantee that the execution is correct, and you don't really need to re-execute. Again, I'm getting into the technical nitty-gritties, but essentially what is to kind of come from more the economic rationales of like this solution, right? Like, so before rollups were invented, the cost of spinning up a chain was that like you had to recruit a big validator set. You had to create like a token to incentivize these validators. You have to make ensure that the token is valuable. You need to build out a community around that, for example. So this whole concept is based on the crypto economic like your security, bootstrapping the crypto economic security, right? Like, and so that's why spinning up a new chain takes a lot of effort. And so you will see like a lot of chains in the wild, but only some of these chains have a very high amount of cryptographic security, and a lot of the chains have very low cryptographic security. And so that's a problem. And rollups came in and they solved this fundamental problem by just simplifying the way in how to spin up a new chain, is in the sense that you have this base layer and you can have n number of rollups, like thousands or millions of these rollups, but none you don't have to bootstrap this economic security. They all inherit the shared security of the base layer. And so now if you see kind of like if you look at a tangible example, right? Like, so like you had optimism or mainnet or the op mainnet by the optimism team, for example, and base from the Coinbase team essentially took the same code base, for example, and spun up a chain. And now they are focusing on more on the chain GTM rather than on building the low level chain infra, for example. And so that is an example where the cost of spinning up chains is now slowly will become so low that you will have this explosion in the number of chains that are there, and then thereby also experimentation in the kind of rollups and so on. So I mean, just to recap, right, like I mean, essentially from a very high level point of view, right, like we are at the stage of blockchain evolution where initially there was this prescribed way to build a blockchain. Now there is this new way to build more blockchain capacity, which inherits, like things like cryptographic security, and so it unlocks a brand new way of, like bringing increasing the throughput of blockchains and getting more and more trust minimized computation. Yeah, hopefully all of that makes sense.
No, that's fantastic, Anurag. I really appreciate you providing that overview. So a lot of our listeners, for reference, are institutional in nature, and I'd say it's probably 50% of them are traditional finance. They're basically dipping in. They're listening to these episodes, different guests of ours, to just learn, and then the other half are native. So for the ones that are trying to learn right now, zero knowledge validity proofs are something that are being talked a lot about. I would venture to guess this isn't going to become more mainstream in the crypto world for a couple more years. But can you elaborate a little bit more on the role of zero knowledge validity proofs, or ZK proofs as they're more commonly called, in Avail, and really just their significance in blockchain technology for the rollup aspect?
Yeah. So in general, as I said, right, like I mean, so zero knowledge proof technology is not specific to blockchains. Of course, it's used in blockchains in a big way. It's primarily can be used in any place where you don't really need to want to share the entire computation and just kind of provide a proof that something has been done. Like it's a little bit like almost like magic in that sense, but but in a blockchain context. So what is happening is, I give this example of a typical conventional blockchain is that there are n number of nodes. That n could be 100,000 or maybe a million. And the problem is that, let's say if you give a computation to this network, it goes to each node in the network, and each node has to run it independently and then arrive at this consensus about the right result, right? Like I mean, and that's how basically ordering, or I mean, in general, chain progresses, for example. Now, this can be very inefficient because you are essentially re-executing all these transactions, or like just redoing all these transactions or computation again and again. Now, what zero knowledge proof, or specifically validity proof technology, brings to the table is this ability to kind of provide a cryptographic proof, or almost like like in a simpler terms, right? Like it's like a bulletproof guarantee, a bulletproof mathematical guarantee that this computation was done. Now, what I mean by computation is, it could be updating balances, it could be updating a particular algorithm in general, or any of the actions that take place in a more let's say a financial use case, or any general purpose use case, right? Like any sort of execution or computation, it can be a kind of it can have a bulletproof mathematical guarantee, and there's this thing called a prover which does this, and it provides one succinct proof. And so the beauty of this is, like, if you want to verify that a certain thing was done, for example, like ledger balances were updated in this certain manner, for example, and balances of X users changed to like A, B, C, for example, and so on, right? Like I'm just giving random examples, but like if you wanted to verify this, the naive way would be to re-execute those and verify for yourself. In the zero knowledge proof way, or the validity proof way, what you do is you have this prover that has this mathematical guarantee that it provides a proof, and you don't really need to re-execute this. You can actually take the proof at face value and know that the execution was done correctly. And so that's why I say this is almost like magic, right? Like I mean, you don't really need to re-execute it. You can just verify the proof and verify. And so this gives superpowers, because suddenly you don't want to have this large number of nodes re-executing everything. It's just this one prover that and then you can actually get this very bulletproof mathematical guarantee. And so that is one thing, and that zero knowledge is used for in blockchains, and it is going to be actually become much more commonplace in areas beyond blockchains as well, right? Like, I mean, you're going to see zero knowledge proofs being used for, let's say, things like authentication, or things like from a more financial use case. I've seen this being experimented with companies doing financial data sharing between entities, for example, and so on, right? Like, this is going to be used in a multitude of ways. Now, just also kind of answering the initial question about how all of this, what all of this, how this ties back to what Avail provides. Also, I'll just provide that as well. In general, from that angle, right? Like, as I said, the first generation of blockchains was built a certain way. The next generation of blockchains is being implemented using the roll-up construct as such, right? Like, and essentially, if you want to do a roll-up, you have to have, like, this is all very low-level infra, but you need to have something called more throughput for what is called data availability, right? Like, I mean, this is the term data availability is a misnomer. It's like poorly worded. It seems to a lot of people like data storage, or like it is like whether proof that the data is available or not. It's actually the more concise terms for this, even though that is confusing, is like data publication, or like whether some data was committed to like a ledger at some point in time. But anyways, basically what I'm trying to say is, like, for rollups you need to have ample or scalable data availability. It's essentially the ordering that a rollup that commits to, right? Like, so for any blockchain there are two things that are important. One, what is the order of transactions, and then what is the result of the execution, validity, or the verification of the execution, for example, right? Like, so these are the two things in any blockchain, in any system per se, right? Like, because if you have a system where there is a certain order of transactions, and if that order of transactions is somehow changed, it also changes the end result, potentially, right? Like, so lot of blockchain fundamentals is about how to arrive at the ordering, like who does the ordering of transactions. And so you can think of data availability as more like the ordering layer. And so you have this base ordering layer where the order of transactions are committed to, and you have this execution happening in another layer. So all of this is very low level infra. But if you want to go from where we are in blockchains today to where we want to be, where we want to get to kind of web scale in terms of blockchains, you really require this modularization of functionality, right? Like, the first generation of blockchains, like, had all of these packaged into one protocol. What we are now seeing is like different layers specializing, but they still need to work together, right? Like, and so that's part of the work that we do at Avail. So we build this state-of-the-art data availability layer, which essentially solves the problem of how do we scale rollups. How can we have like this world of 1,000 rollups, or 10,000 rollups, or 1,000,000 rollups, for example. And but we don't stop there, right? Like, we basically say, okay, we are going to enable this world of 1,000 or 1,000,000 rollups now, but what is going to happen to then, like, the user experience at that point in time, when users have to think about multiple rollups, multiple chains, switching RPCs, for example, bridging from one chain to another. And so, like, we don't stop at just the DA part of Avail. We also build on top things like Avail Nexus, which is basically a more roll-up interoperability protocol that kind of unifies all these thousands and millions of rollups together, right? Like, so we do use this again using primitives like data availability sampling and proof aggregation and such. But like, the high level view is that we are moving from this conventional paradigm to a newer roll-up centric paradigm of scaling blockchains, and we need to have infra that supports scaling of rollups, but then also how can these rollups talk to each other, and so on. And so that's how we want look to define the vision of Avail.
It's absolutely fascinating. Thanks for that overview. Scaling's obviously been a topic for many years that people are concerned about. Excited to see that you guys are pushing to help solve that.
Yeah. No, I'm kind of trying to cradle being as technically accurate as possible, but also kind of simplifying the message, and hopefully I'm able to simplify it as much as I can.
Well, this actually really dovetails nicely what you were just explaining with the DAS, for instance, and how we just recently Avail launched the light clients. And so now anybody has the ability through the use of these light clients to do that data availability sampling. And so that's a really unique feature that's just getting rolled out. So if you guys haven't, if anybody's watching or listening and you haven't checked that out, it's open for anyone. You don't have to be running a validator or anything else like that. Anybody can run one of these light clients, which is truly amazing. And what's interesting is, though we talked a lot about sort of the cryptographic security through the validity proofs, there's also in the future part of the map with the Nexus where there's almost crypto economic proofs that are added on top, like optimistic rollups, because eventually part of the roadmap is where the non-native tokens to Avail will also help provide that economic security. Can you fill us in a little bit more about like what's coming for Avail in the future?
Yeah, as I said, right, like, I mean, we are quickly moving into this roll-up centric future in the world of blockchains, right? Like, so, I mean, those of you are kind of not in the weeds of what is happening there. Like almost every day, there's a new roll-up being launched, right? Like, I mean, like if you go to something like L2 Beat, there are like, I think north of 40-50 chains already listed, and the upcoming roll-up list has another 50 or 100 chains. But if you go to Twitter, like, there's just almost every day there's new rollups being launched, right? Like, because the cost of spinning up this rollup has become is going lower and lower, right? Like, so what has happened is teams like Arbitrum, Optimism, Polygon, zkSync, Starkware, and others like Sovereign Labs, Stacker Labs, for example, and so on, have been, of course, they have built these rollup of their own, but they also now commoditize their SDKs in general, and so which enable any team to now kind of pick up that chain SDK and then like spin up their own rollup. So like Base from the Coinbase team is one very good example where kind of they just kind of took that SDK and spun up a chain, and like you're seeing a lot of activity on Base, for example, and there's multiple other examples of this. And so already I see that probably the number of rollups are in the hundreds, and each these rollup stacks are quickly maturing pretty fast, and so in that sense, like, we see that we are getting to go into a world of these thousands of rollups, right? Like, I mean, and they all need like, of course, Avail DA to scale up. But once we are I think we are already there, where like users are now trying to make sense of what rollups to transact on, how to take money from one chain to another, for example, or from a chain perspective, it's becoming difficult from a GTM perspective to figure out how do I make the friction of bringing users from other chains to my chain, bringing liquidity from other chains to like my chain, for example. So those kind of questions are being kind of now asked in general. And so this tooling around how do we connect these rollups together, right? Like, instead of, like, if you kind of look at it, right, like from a workflow of a user, if you are on let's say a Arbitrum rollup, and you have, let's say, funds on Optimism, for example, now if you want to bring some funds over to Arbitrum, today what you have to do is you have to bridge your funds from Optimism back to Ethereum. It like the withdrawal takes 7 days, for example, and so on, and then you have to kind of come back to Arbitrum. Of course, there are some fast bridges as well, but they have a different set of trust assumptions, for example. But like, so essentially you have to route all this chain interoperability via Ethereum, and that's pretty expensive for users. And so if we want to kind of go beyond this to actually see all these rollups succeed, you need to think of ways that kind of like solve problems of for a new chain developer, which is who is asking these questions of how can I make the friction of getting more users from other chains to my chain a reality? How can funds move quickly without going through Ethereum, for example, and so on, right? Like so those are kind of the questions that like Avail Nexus really answers, for example. And from I think what you also ask is like about Avail Fusion, which is our like the initiative that we announced a few weeks back, which is about adding more cryptoeconomic security to this base layer. Because in a sense, what we are doing is we are trying to really build out the unification layer for like for all these rollups together. And what we feel is for this layer, it requires unified security. And so apart from the native Avail token, we also enable users to stake things like BTC and ETH and other tokens also in the at the base layer, right? Like so that's kind of what we are aiming for.
It certainly seems like you have architected quite an ambitious and holistic vision for what the future is going to enable all of us to do as we become more and more interoperable. It's interesting too that out of all the SDKs that Avail chose the Polkadot SDK to work with and Substrate and so on and so forth. So it's just really cool to see how you've cobbled together all these different blockchain ecosystems, and there's such a groundswell, in the Avail community, and just people are so positive about what you guys are building. So thank you so much for taking the time, Anurag, to actually talk to us today and give us, all this great overview of how this is going to work and what's coming in the future. What's the best place for any listeners or viewers to reach out to you? How do you want people to connect with you?
Yeah, I think I'm pretty much open to reach outs on Twitter, for example. My DMs are open, and like I regularly check Twitter DMs. So if anyone wants to reach out, Twitter DMs are best. But otherwise, in general, you can go to our website if you want to reach our team. There are various ways to contact the team via Telegram, Discord, and so on. But in general, we are quite open, and we listen to all of these channels too. And and if you're kind of looking to reach out to us, please feel free to DM.
Thank you so much for taking the time, Anurag. Honestly, and for those who are watching and viewing, if you haven't, or listening, if you haven't had the chance to read the Avail thesis that was written by Anurag, I cannot recommend it enough. I just refreshed myself reading it beforehand. Really exciting stuff that you guys are building. Thank you so much for taking the time to be with us today. Really enjoyed running through all the Kate testnets and Goldberg and everything else that we've been doing, partnering with Avail here at GlobalStake. So thanks for taking the time, Anurag, and we'll be sure to link a lot of these resources and ways to connect when we put these episodes out very soon. Thank you for everybody who has been listening and watching, and we'll see you next time. Take care.